Okay, guys, I screwed up, and when I videoed today, I did not have my sound playing. So I'm redoing this again, and I'm going to start posting these to YouTube so it's easy for you to get to them because I guess so many teachers are having to do this kind of stuff now that it's overwhelming Google Classroom. So I now have a YouTube channel, I now have playlists, so I'm now a YouTuber. Um, so anyway, I want to go ahead and go through these with you guys so you have this if you weren't able to listen to me when I did it live in class. So we're going to start talking about 8.5 and 8.6 today. Yesterday, 8.4, this was 8.4. These guys right here, when you clearly had a top and you clearly had a bottom, and you clearly had an upper function and a lower function. So what we're looking at here, this is your left-hand side, your right-hand side, your upper, and your lower. So this is all 8.4 right here. They're not always like that though. Sometimes you get graphs that look like this, functions that are more vertical looking, and there's no clear top or clear bottom. You have a clear left and a clear right. If that's the case, all of these guys over here from 8.4, all of this is like y equals x stuff, or f of x equals x, blah, blah, blah. Over here, it's all x equals y, blah, 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 blah. So over here, everything is going to be in terms of y. And you have the bottom, your upper bound's the top, and it is your right function minus your left function. And all of these are in terms of dy. All of these are in terms of dx. And this is top minus bottom, upper minus lower, and this is the right-hand bound. The upper is the right-hand bound, and the lower is the left-hand bound. So basically what I'm going to do today is I'm just going to do, it looks like 5 examples of this type of problem. So the first one we're going to look at is find the area bounded by these two. Now notice you're just given two functions. You're just given this guy and you're just given this guy. So if I can, I want to solve it for y. But if I come over here and I solve this for y, I'm going to have y squared equals 3 minus x. And when I take the square root, I don't want to kill any small woodland animals, so I'm going to put a plus or minus in front of it. So that means I would actually have two different functions here, and I don't want to have to deal with that. So that's why we go ahead and we do it in terms of y instead. So I'm going to go ahead and get rid of this. I don't want to leave that on there. So what I'm going to do now is I'm going to sketch these. I know if it's x equals 3, this tells me which way I'm moving this way. It's kind of almost like I'm taking the axes and they're flipping spots. So I'm going to go 3 this way. And this, the minus sign, tells me it opens towards the minus side. If this was a plus y squared, it would open towards the plus side. So now I'm not real sure what this looks like. What I'm going to do is I'm going to come over here, and instead of putting x's in, I'm going to put y's in and find out what my x does. So it's opposite of what we're used to doing. So if I make this little table, because I'm going to try to make this look a little bit better than I did the first time. If I picture y being, let's say y is 1. If y is 1, x is going to be 2. So over 1 up 2. If y is negative 1, I'm still going to have x is 2. So I know this is a parabola, so please forgive me. I'm going to try doing that parabola thing. We got a parabola. I thought I saw one on here somewhere. Somebody said they saw one on here. I'm not seeing it now. Bummer. Okay, so I'm going to come over here, back to focus. I'm going to have a parabola that does that, and the top piece does that, and I am pretty impressed with myself. That's a pretty good looking parabola. Now we're going to look at the x equals y plus 1. And this is just a line, so it doesn't matter. I can go ahead and do that to it. Come down here to negative 1, over 1, up 1, over 1, up 1, down 1, over 1, down 1, over 1. And I will go ahead and connect those lines. Okay, so what we're looking at now is we're looking at this area. Let me shade it in. We're looking at this area in here. Okay. Now I tried to do a decent job of graphing it, but it's still not great. So what I'm going to have to do now to make sure I know what these intersection points are, I'm going to take the 3 minus y squared and set it equal to the y plus 1. And if I do that, I'm going to take everything to the right-hand side to make that positive. So I added y squared to both sides. I'm going to subtract the 3 from both sides. And if I go to factor it, I'm going to have y plus 2, y minus 1. So my y's intersections is at y is negative 2. So that should be, so I drew this one too big. That should be what? Negative 2 somewhere in here. And then y is 1. And that's up here. So I don't know what I did wrong. So obviously I didn't graph it very well. But I do know the bottom is a negative 2. The top is a 1. So now I have to do the right-hand side. So I'm going to say 3 minus y squared minus, and this is where you got to be careful. You have to make sure to put that second piece in parentheses, because if you don't, you're not going to distribute that negative, and you don't want to get it that right and screw it up right there. Okay, so you really want to make sure that you take the time to put that in parentheses, because there's a reason why you have to do that, because if you don't, you're going to screw it up. Basically, I say that, I know it because I know I screw it up. So now I'm going to go ahead and come in here, combine like terms. I got a negative y squared and a minus y and a plus 2 dy. Are you okay with that? So now if I antiderive this, I'm going to have a negative 1/3 y cubed minus 1/2 y squared plus 2y, and I'm going from negative 2 to positive 1. Now I'm going to go ahead and tell you through the miracles of modern magic. Let me see if I can get it to pop up here for me. It's not liking what I'm doing. Hold on a second. I'm having a little bit of technical difficulties here. Okay, so once again, through the miracles of modern magic, I am going to have the answer. If I sub in 1 and then I sub in the negative 2, I'm going to end up with 9/2. Okay, so again, make sure you sub in the 1 and then minus. Make sure you sub in the negative 2. And if you do that, you should get 9/2. So let's go on to the next one. My next one, sometimes they're going to give you more ways to have it bounded, basically. So my green is this guy. And if you notice, it's back 2. And then it's a positive y squared, so it's open towards the positive side. And then we have our next one is y equals negative 1. It's purple. That's this guy right here. And then we have the y equals 1. And that's this guy right here. And then we have the x equals e to the y. And that's the red one right here. So what we're looking at, the area that we are going to encompass with this is going to be above this purple line, below this black line, and then in between them. So that yellow is what we're doing. So again, we're going to be going, it's a left to right one. So we're starting at the bottom. We're going to the top. The right hand minus the left hand. And watch how I do this time. I went ahead and distributed it. So I end up with each. Okay, I'm stuck in a group chat with family, and they are going on about cats right now. Let me silence them. Okay. So now, if I antiderive this, I get e to the y minus 1/3 e cubed plus 2y. That's a plus sign. It's a big plus sign. From negative 1 to 1. And if I sub everything in, I end up with e minus 1 over e, or e to the negative 1, plus when I add up all my constants, 10/3. And that's the area in here. And you don't have a calculator, so that's how you leave your answer. That's your most exact answer. Okay, now let's look at this is example 1. This is actually, I think, 8.6. There was just a couple examples from 8.6, and I added one more to it. With this, sometimes you have them that intersect in more than one point. So if they intersect in more than one point, what you have to think about here is how they're going to intersect. Now, you know, this is a cubic, so odds are it's going to do this. And you know, this is an upside down parabola, so odds are it's going to do that. So notice, I don't have a calculator. But for the sake of time, I'm going to come over here and graph it, just so y'all can see it, and you don't have to sit here and listen to me stumbling through all this, how I'm doing it. I guess, can I come in here and just type TI? Oh my gosh, what just happened? TI. Oh my goodness, I could just do that instead of scanning for it every time. That's so much smarter. Okay, so I'm going to graph these two, and I'm going to see what happens. Yeah, no, next. Okay, so I'm going to y equals, clear out what's in there, and now I'm going to have 3x cubed, making sure I arrow down from that one, minus x squared, minus 10x, and underneath there, I'm going to have a negative x squared plus 2x. Now, here's the deal. Technically, I don't have a calculator, so I'm going to hold off showing you that for a minute. What I am going to do is I'm going to come over here, and if I need to find the points and I don't have a calculator, the first thing you're going to do is you're going to take these two and you're going to set them equal to each other and try to solve. And hopefully we can do this without a calculator. I'm going to take everything to the left-hand side because this x cubed is positive. If I add x squared to both sides, the x squares go away. I'm going to subtract 2x from both sides, and I'm going to end up with this. I can factor out a 3x, and we're left with x squared minus 4. And then I've got x equals 0 from this piece, and x equals negative 2 and positive 2 from this piece. So I can see right now I have 3 places at x equals 0, at x equals negative 2, and at x equals 2. So I'm going to have more than one piece that I'm going to have to find the area of it. I'm betting this thing is going to go like this. And I'm betting my parabola is going to do something like that. That's my guess. So I'm going to come over here and check it out and see if I'm right. So I'm going to hit now. Notice this window here. I'm going to go to my window and I'm going to make it match this. So I'm going to say negative 3 to 4. My y min is negative 10. The top, I'm just going to leave that negative 10 and 10. And I'm going to hit graph. So there's my cubic. And there is my quadratic. Now notice I put those on the x-axis. That's not necessarily where they're going to be. I just know that somewhere on here, and somewhere on here are where they're going to intersect. So I'm going to come over here and take a picture of this so I can write on it a little bit and talk about it. Okay, so I'm going to pull it over here, make it bigger. So if you'll notice, at negative 2, at 0, and at 2 is where they intersect. But we can't just go from negative 2 to 2 because if you'll notice, the blue one's the top here, but the red one's the top here. So we're going to have to go from negative 2 to 0. My blue one is my cubic, so I'm just going to put f of x. My red one is my quadratic. And I'm going to add to it from 0 to 2. But this time, my red one is on top. So my quadratic goes first, and my cubic goes second. And then basically, you're going to do this side by itself, get an answer. You're going to do this side by itself, get an answer, and then you're going to add those two answers up. And honestly, I don't remember if we kept the numbers in there or not. I don't think we did. Let me see real quick if I got anything in here. Because I did pre-cal after I did. Oh, the answer is right here. The answer is 47.333. And I know that you wouldn't be able to use a calculator, but just for the sake of time, I'll do that. But this, you could all do that by hand. You're going to just make sure when you put these in here that you have that second term in parentheses. Okay, 2 more to go. This guy right here, we have to determine the area of this, and they've given us the bounds. But have they? Oh, you know what? That answer might be for the next one. So I'm going to erase that because it might be for the next one. I'm going to go back and look at my calculator and see. Yeah. So ignore that. I don't remember what the answer to this is. I think it's on the PDF. If you want to see it, you can see it there. So if we're looking at this one, I think those are my bounds, but I want to make sure. So I'm going to go ahead and take and set the two functions equal to each other. And I've learned a long time ago not to trust calculus people. So I'm going to move everything to one side where the x squared is positive. I'm going to be able to factor out a 2 and divide 0 by 2, and it's going to magically disappear. And I'm going to factor this. If I factor this, I get x minus 3, x plus 1. So if you'll notice, these don't match these. So basically what we have is at -2, at -1, at 3, and at 5, we have 1, 2, 3 different areas. So I'm going to show you right now. This is what it looks like. So we're going to have to actually take this and cut it up into 3 areas. So the moral of this story is don't trust calculus people. Because if you went from -2 to 5, you would have gotten it wrong. What you're going to have to do, you're going to have to break it up into 3 pieces. From -2 to -1, the red one, which is the parabola, is on top. We're subtracting the linear one from it. And I would get that and get an answer. And then I'm going to have from -1 to 3. And this time the line is on top. And I'm going to minus a quadratic. And then, go away you. And then I'm going to go from 3 to 5. The quadratic's back on top. So what we have here, we basically have 3 pieces, the black, the red, the blue. You're going to come up with each of those answers individually, and then you're going to add those up. And that was the answer that we had on here. I always do that. And that's a 47.333. But again, notice not a calculator problem. I'm just going to put that down there so you have it. Okay, so I was looking at the homework, and this was the end of the notes that I had. And I was looking at the homework, and there was a problem like this. And I knew that you all would look at this problem. I'm going to give you about 30, or pause it, read it. Okay, so I knew you'd get a problem like this, and it would flip you guys out. So what we have here is we have this region in here. It's enclosed by this quartic, and it's enclosed by this horizontal line. So we have a point here and a point here. And we want to find a vertical line. Let me get a line on here. We want to find a vertical line that will cut this region into 2 equal pieces. And we don't know really where it's at. We're just saying it's somewhere, and we're going to call it K. And we don't know where it is, but we just know that this half of the R equals this half of R. So my problem is I've got to figure out what my outer bounds here are. So I'm going to say x to the 4th minus 2.3x cubed plus 4. It has to equal 4 because here and here they're the same value. So I'm going to subtract the 4 from both sides. If I do that, they actually cancel out on both sides. I'm going to factor out what they share. And I get x equals 0 from the left-hand term, and x equals 2/3 from the right-hand term. So this is 0, which I thought that was 0 anyway, but like I said, I don't trust them. And this point right here, did I say 2/3? I meant 2.3. Is that kind of the same thing? It might be. I don't know. So now I have to find out, it says write, but do not solve. So don't go any farther than you have to. An equation, so it has to have equal sign in it, involving integral expressions whose solution gives a value of k. So basically what we're going to do, we're going to say from 0 to k is a set. And we're going to say 4 minus, and I'm just going to put f of x because they've told us what f of x is. Okay, so that's this in here. Now, if I divide this into 2 equal pieces, this side in blue should equal this side over here in black. So I'm just going to put equal. I'm going to write down here because I'm running out of room. From k to 2.3 of f minus f of x dx. And I'm done. That's all I have to do. I write it, but I don't solve it. So I'm done with the lesson. I did tell them that Monday you are going to have an 8-4 to 8-6 quiz. Monday is when your 8-4 to 8-6 homework is due. So be aware that's coming up. They'll probably be on My Open Math like they usually are. And if there's an FRQ, I will figure that out later. But that's it for this. So I hope it actually recorded the sound this time.